All right, let's dive into the invisible world that makes our modern lives possible. We're going to pull back the curtain on the technology that acts like the glass nerves of our entire planet.
So just stop and think about that for a second. Every single thing you do online, every video you stream, every message you send has to physically travel, sometimes thousands of miles. How on earth does all that data get from here to there in the blink of an eye?
You know, the answer is so simple, it's almost poetic. It's light. Pure pulses of light, flashing through impossibly thin strands of glass. We're not talking about electricity in old copper wires anymore. This is something else entirely.
Okay, so to really wrap our heads around this, we've got to start with the absolute basics. What exactly is this stuff that's become the literal backbone of the internet? At its heart, the idea is pretty straightforward, right? You're basically encoding information, ones and zeros, into flashes of light. Then you just shoot them down a tiny glass tube. But the jump from using electrical signals in copper to using light in glass, well, it's like going from a horse and buggy straight to a spaceship. It's a total game changer.
Now, you can probably guess that this isn't a one-size-fits-all situation. The kind of cable you'd need to stretch across the bottom of the Pacific Ocean is going to be a little different from the one connecting computers in your office. Let's get into why.
Okay, so you've basically got two main flavors of fiber. On one side, you have single mode. Now its core is tiny, like the width of a human hair, and it uses a super-focused laser beam. This lets one single path of light travel for insane distances. We're talking over 100 kilometers. That's why it's the champion for long-haul stuff like telecom networks and those massive undersea cables. Then you have multimode. Its core is bigger, and it uses a less intense light source, like an LED. This means the light kind of bounces around inside, taking multiple paths. It's cheaper for sure, but the signal fades out way faster. So it's perfect for shorter distances, like wiring up a data center or an office building.
And it's not just about what's on the inside of the fiber. The outside matters a whole lot too. Indoor cables are built to be flexible and easy to work with. But the second you take that cable outdoors, it needs to get tough. We're talking loose tubes filled with water-blocking gel or even layers of steel armor. And you know why? To stop things like backhoes and, I'm not kidding, to stop squirrels and gophers from chewing through your connection to the world.
So with all this amazing power, you might be thinking fiber optics is the perfect technology, right? Well, not so fast. Like pretty much everything in engineering, it's all about the trade-offs. It's got some incredible upsides, but also some pretty serious downsides.
Let's start with the pros. And wow, are they huge. First, bandwidth. The amount of data you can push through fiber is just astronomical compared to copper. And because the signal barely fades, you can send it for really long distances. It's also completely immune to electrical interference, so you can run it right next to a high-voltage power line with no problem. But my favorite part is the security. You can't just secretly tap into a fiber line. To steal the data, you'd have to physically break the path of light, and that's something that gets noticed immediately.
But here's the flip side. Remember what it's made of? Glass. And glass, well, it breaks. It's incredibly fragile. You can't just hire any electrician to install it. You need highly skilled technicians who are basically like surgeons for these tiny glass threads. They use expensive, specialized equipment to fuse and test everything. And get this, even a single speck of dust or a bit of moisture on one of the connectors can mess up the signal and take down an entire network. It's powerful, but man, is it delicate.
And that sensitivity brings us right to the main bad guy in the fiber optic story. It's this constant battle that technicians have to fight against the signal slowly dying off. It's a phenomenon with a name: attenuation.
So what is attenuation? Well, it's just the fancy word for the light getting dimmer as it travels down the cable. Think about shining a flashlight across a huge, dark field. The beam gets weaker and weaker the farther it goes, right? It's the exact same idea here. And in the world of data, a dimmer light means a weaker signal and eventually lost information.
So what's causing this? Well, there are a few culprits. First, even in the most pure glass imaginable, there are still some tiny impurities that can actually absorb the light and turn it into a little bit of heat. Second, you've got scattering. Microscopic bumps or defects in the glass can cause the light to bounce off in random directions instead of going straight. And finally, there's just plain old bending. If you bend the cable too sharply, the light can literally leak right out of the core.
So, how in the world do you fight an invisible enemy like signal loss inside a hair-thin strand of glass? Well, you can't just look at it. You need a pretty amazing toolkit that lets technicians see the light and diagnose problems they could never find with the naked eye.
This is basically the high-tech detective kit for fiber tech.
The simplest tool is the Visual Fault Locator, or VFL. It's basically a powerful red laser pointer. You shine it down the fiber, and if there's a break or a bad connection, you'll see a bright red glow right at the problem spot. Then you have an OLTS, which is kind of like a report card. It measures the total signal loss from one end to the other and tells you if the cable passes or fails. But the real star of the show is the OTDR. This thing is like sonar, but for light. It sends a pulse down the fiber and analyzes the reflections that come back, creating a detailed map that shows the exact location of everything. Every connection, every sharp bend, every single fault, down to the meter. It's incredible.
Okay, so this whole amazing ecosystem of cables, tools, and technicians, it doesn't just appear out of thin air, right? This global nervous system is being built and innovated by a handful of really big, really important companies all around the world. And here are some of the heavy hitters on the world stage. You've got Corning, right here in the USA. They're the pioneers, the wizards of glass science, who pretty much invented the usable fiber optic cable. Then there's Prismanian Group out of Italy, the biggest cable manufacturer on the planet. And you have other huge players like Sumitomo in Japan, UFOC in China, and Nexans in France. Each of them has their own specialty, from making the raw materials to building those giant armored cables that lie on the ocean floor. It's a truly global effort.
So I want to leave you with this one final thought. We have built our entire robust, high-speed digital civilization on a foundation of something that's fundamentally fragile. Think about that. Our world's constant connectivity depends entirely on keeping these delicate, brittle threads of light perfectly intact. It's a wild paradox, and it's something to think about the next time you hit play and a video starts instantly.